Today we will start a new course, Control Systems. So we'll go with the first module, Basic Components of a Control System. Before going into the basic components of a control system, let's see what is a system and what is a control system. A system can be defined as a collection of components or elements that are connected together in a sequence to perform a specific task or a function. So that is basically a system. In a system, if the output quantity is controlled by varying the input quantity, then that system is known as a control system. So how will you define a system? We can define a system as a collection of elements or components connected together in a sequence to perform a specific task or a function. And in a system, if we are varying the output quantity by varying the input quantity, or if we are controlling the output quantity by varying the input quantity, then the system is known as a control system. So now let's see what are the basic components of a control system. So basically, a control system has three important components or three basic components, which are objectives. Objectives are nothing but the inputs. Then secondly, we have the components of the control system, and finally the results or the outputs. So we have a control system or control system components, and we are applying the objectives, or we are applying the inputs to the control system, and from that system we are getting the output or the results. So the basic components of a control system are objectives, which are also known as inputs or actuating signals. Then secondly, the control system components, and finally the results or the outputs. So these three are the basic components of a control system. So we have seen what is a system, so what is a control system, and what all are the basic components of a control system. So now moving on to the next part, applications of control system, or say examples of control system. So you may be asked to list out the different applications of control system, or you may be asked to write the different examples of control system. For both, you can go for the same answers. So applications or examples of control system. So first one, a temperature control system. So here you can see an electric furnace. We are trying to increase the temperature of that furnace, or we are trying to control the temperature of that furnace. So through a relay control circuit, we are applying AC. So we are applying that voltage to the heating element of the furnace. So obviously when we apply that supply, the heating element will start to heat, and as a result its temperature will slowly increase, right? So we have placed a sensor over there to sense the temperature, and the temperature is being converted into a digital quantity so that we can display that temperature in the digital display. This is some sort of control system we have, but we normally say that this control system, this temperature control system, is a open loop system. So why do we say that it's an open loop system? Because we cannot automatically correct the temperature. So that's why we say that it's an open loop system. Actually, there are two types of control systems: open loop control system and closed loop control system. So we'll discuss all those in detail. Okay, so this is a kind of open loop control system. We are just applying AC supply to the furnace through a relay. So when we supply that AC, the temperature of the heating element will slowly increase. Okay, and with the help of a sensor we are measuring that temperature, measuring that quantity, and it will be in analog nature, so that is converted into digital with the help of a analog to digital converter, and that is being interfaced to a digital display so that the digital value corresponding to the temperature can be displayed in the digital display. And in this case, if I want to say reduce the temperature of the heating element, or I want to reduce the temperature in the electric furnace, so what I need to do is I need to switch off the AC supply manually. So when I switch off the AC supply manually, slowly the temperature in the electric furnace will reduce. And after some time, if again I want to increase the temperature in the furnace, what I need to do is again I need to switch on the AC supply manually. So to control the temperature in the electric furnace, we need to switch on or switch off the supply manually. So here there is nothing that we can control automatically. So that's why we say this is an open loop system. We cannot do automatic corrections. We cannot control in an automatic way. But we can convert this system into an automatic control system. So that kind of automatic control system is known as closed loop control system. So what you can see here is an open loop system, but if we are able to control the temperature automatically, then that kind of system is known as closed loop system. So I will show you the diagram how to convert this system into automatic system. See here, this is a kind of closed loop temperature control system. The difference we have made is here, just we have added a controller over here, right? So to the controller we will give the desired temperature or the reference temperature. So this is the temperature that we need in the electric furnace. The controller also accepts signal from the furnace side. So that will be the actual temperature in the furnace. So now what the controller will do is it will compare the actual temperature in the furnace and the reference temperature we have given. And based on the comparison, the controller will generate an error signal. That error signal is actually fed back to the relay circuit. So that error signal generated by the controller can be used to switch on or switch off the relay. Okay. Suppose the temperature in the furnace is higher than the temperature that we require. The temperature in the furnace is higher than the temperature that we require, or the desired temperature. So what the controller will do is it will generate an error signal, and that error signal will be used to switch off the relay. Okay. So if the relay is switched off, then automatically the supply to the heating element will be switched off. So slowly the temperature in the electric furnace starts to reduce. And after some time, when the temperature in the electric furnace becomes lower than the desired temperature, again what happens is, based on that comparison, the controller will generate an error signal, and that error signal again will be fed back to the relay circuit, and now this error signal will switch on the relay circuit. So this kind of automatic switch on and switching off of the relay circuit ensures that the temperature in the electric furnace is the desired temperature. So this system will keep a constant temperature in the furnace. So this is how we make a closed loop temperature control system, or a automatic temperature control system. Now we'll go to the second example or second application. So this is the thing you all know. It's a traffic control system. Okay. So again, our normal traffic control system is open loop system. So why we say that it's open loop system? Because it's based on a timer. Okay. So based on a timer, it will open a particular lane and it will close other lanes, and after a particular amount of time it will open the next lane and close all other lanes likewise. So it's based on a timer. Again, we can convert this kind of traffic control system to a automatic traffic control system or to a closed loop control system. So how can we do that? We can do it by measuring the amount of traffic in a particular lane. So maybe with the help of a camera. So if the traffic in a particular lane exceeds a particular limit, we can open up that particular lane and we can close other lanes. Okay. So likewise we can convert the normal traffic control system to a closed loop control system. Okay, steering control of an automobile. The movement of the tires is done with the help of a steering wheel. Okay. We will control the steering wheel. We will rotate the steering wheel, and based on the direction of rotation, the tires or the wheels will move accordingly. So likewise we are controlling the direction of the wheels. Okay. So that can also be considered as a control system. Then speed control of a mobile. So how do we control the speed of an automobile? It's done with the help of a accelerator, right? So we are pressing the accelerator, so we'll be applying a force on the accelerator, right? So that will change the rate at which the fuel flows. So based on that, the speed of the automobile will change. So in this case, the input is the force that we apply on the accelerator pedal, and the final output or the controlled variable is the speed of the automobile. So controlled variable, that means the output itself. Okay. So these are the different applications or examples of a control system.